here we go. So this, I would say this is a little trickier, like I said, and therefore you definitely would want to look at the book chapters if you don't totally grasp it right away in lecture. Mostly chapter 9, but a little bit of chapter 8 also. Okay, sometimes we have problems where we're trying to search through a set of possible answers to find the right one. And we call those exhaustive search problems. And we've done exhaustive searches before. Like if you're looking for something in a vector, you just loop over all the elements and look for it. That's pretty easy. The thing is, sometimes it's hard to even enumerate all of the choices. Like it's easy to enumerate all the choices in a vector. You just loop over them. Int I goes 0 to size minus 1. Those are all the choices. But like, what about all possible, like this class, you guys are pairing up to work on assignments, right? What if I wanted to know all possible pairings that anyone could make with anyone else? There's lots of possible pairings. Each of you could pair with any other one. What if I wanted to print out all the possible pairs? Well, that's not that hard either. But what if I said, hypothetically, what if we were allowed to work in groups up to 10 or up to 50? What if I wanted to print all the possible groups that could ever be made or something like that? It's really hard to write code to enumerate all of these choices sometimes and maybe look for possible things in the data that are of interest to us. We call these exhaustive search problems. It turns out that recursion is a really good algorithmic pattern for doing exhaustive searching, because recursion is really good at sort of exploring down different paths using recursive calls. So here are some particular examples here, like generating, if you wanted to write a program to crack passwords, this kind of stuff is useful for that. Of course, we would never do that because we're good guys and gals here. We're not bad people. But things like this. Another example would be like if you're writing a computer that was going to play chess, you're going to write Deep Blue to try to beat the chess grandmaster. You wanted to look at all the possible chess moves, and if I move here, then my opponent's going to move here, and let me plan out 10 moves ahead. Let me just enumerate all the possible moves, and let me look at which one's the best for me. That's another example of searching a space of solutions to a problem. Okay, if you're going to write code that searches exhaustively through a solution space, there's kind of this general pattern that your code usually has. And it's recursive. And the pattern is something like the following. You have some sort of function, recursive function, that's going to do searching. And you're being passed some parameters representing the space of things to search through. And I call it sort of your decisions or your choices or something like that. And the way this code usually functions is you say, well, if there are not any decisions left to be made, I'll stop. But if there are decisions to make, I will choose to handle one of these decisions. For each possible option, I'll try it and explore what could come next. So I guess the example would be like if I'm playing checkers or chess and I want to explore all the possible moves I could make and figure out which one's the best one. Let's talk about checkers for a second because it's simpler. Let's say I have 5 checkers on the board. Sort of for each of my checkers, I could consider all the different moves I could make for that checker. So maybe I'll try making a move with one of the checkers, and I'll explore all the possible things that could happen after that, and I'll see what I get. That's kind of the idea here. And we call this the search space that your code is walking through. Okay? So here's an example problem that is kind of in this domain of exhaustively searching. I want to write a function, a recursive function called printBinary. We did some stuff with binary before, I think. And I want to print recursively all the binary numbers of exactly that length. 2 characters, 3 characters, or 2 bits, 3 bits. Now, you might say, what? Isn't that just a for loop? I mean, is Marty just forbidding the for loops again or something? That seems like that would be easy to do with a for loop. But I think if you think about it for a while, it's not quite as easy to do with a for loop as you thought, because you really end up wanting loops related to each digit or something. And if you don't know how many digits you're going to have, you don't know how many loops you need. And it's a little trickier than you might think to do with loops. But you see I've got a Socrative logo up there. So I want to ask you something about this code for a second. Okay? So let me pop up my Socrative and get that up on the screen. Sorry. Email. And let's do a new multiple choice question. That's quite a large font. OK, there. So what's happening? What's happening? Wait, what? 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 Oh, it's some sort of animation thing. Great. Wow. I think what that's supposed to do, I mean, I made this slide, so I think what it was supposed to show you, when you're doing recursion, you're always looking for self-similarity, right? How is printing binary like printing binary? And I want you to look at like printing all the 2-digit binary numbers. That's related to printing all the 3-digit binary numbers, right? Because if you look at, I mean, for some reason, the little green rectangles don't line up properly, but this blob of text appears over here, kind of on the side of these 4 lines of output right here. Do you see the second and third digits of this output are this output? And again, the second and third digits of the second 4 lines are another occurrence of this output, right? And what's the difference between the 2 clumps of 4 on the 3 side? They are preceded by a 0 or by a 1, right? So, I mean, that seems to show us a lot about self-similarity here in this code. So it seems like if you were just describing this in English, the difference between printing 2 and printing 3, it's sort of like you print a 0 followed by the previous one, and then you print a 1 followed by the previous one. You know what I'm saying? Like, that's kind of what's going on here. Seems like we've got the gist of it recursively wise. OK, so what's my Socratic question? Well, if we're going to write a function called printBinary, and we take how many digits in as a parameter, what's a good base case? Here are some choices. If you were writing this, what do you think you would make into your base case? Take a look. Talk to your buddy if you want to. Give you a few seconds. Cast your vote if you haven't voted yet, please. Well, let me show you what you guys said. The most common answer was D by a pretty large margin. So D is the one that says there's only 1 digit left to choose, right? OK, only 1 digit left to choose. Fine. So let's write it, and let's use that. Since you guys are telling me that that's what you want as a base case, let's go try to do it. Let's go try to write it. So printBinary. I've got a cute creator file here. I've got one called printBinary. We're going to go down here and write it. I sort of show up with these testing programs ready to write in our part, you know. So OK, you said when there's only 1 digit left, so if the digits is 1, that's pretty easy. So all the binary numbers of length 1, what are they? Just 0 and 1, that's right. So 0, endl, cout, 1, endl. We don't have to have the quotes there, I guess, but whatever. OK. So else, so that was the base case, right? Easy. And then else we have multiple digits. This is a recursive case. And you sort of told me, like, print a 0 followed by the next one, print a 1, something like that, right? OK, so do I put cout 0 and then print binary digits minus 1, something like that? That's kind of what we're talking about. So preceded by a 0. And then here, cout 1 and do print binary digits minus 1. OK, let's try it. So in main, I call print binary 3. Well, that's not quite right. I mean, we printed 0, 0, 0, and that's the first line of the output I want. And then I want 0, 0, 1. And what we actually print is 1. And then I want 0, 1, 0, but we only print 1, 0. And I always think of the line from the Matrix where he's like, I don't even see the binary anymore. I just see blonde, brunette, redhead. I never. OK, so it seems like this is printing some portion of the right output. That 1 is kind of there at the end of that line of output, and that 10 is kind of at the end there. But it's just not doing quite the right thing. So I want you to understand that this is not quite right, and it's not going to be easy to patch, because this here is sort of a fundamentally flawed understanding of what code does. I mean, I wrote it, so I'm making fun of myself, I guess. But like print binary, if I say print binary digits minus 1, let's pretend digits is 3. So let's say print all the 2-digit binary numbers with a 0 in front of them. Let's really think about that for a second. This prints 4 lines of output, right? If I print a single 0, that's not going to magically put a 0 in front of each of those 4 lines of output, right? It's just going to put 1 0 in front of the first of those 4 lines of output. So, like, I want to print all of these lines, but somehow insert a 0 at the front of those lines. But the code I've written is not going to do that. You know what I mean? Does that make sense why that's not going to happen? So, seems like we need to rethink this a little bit. How do I insert something at the front of all of the lines? Yes, sir, you have an idea?
Put the print binary in a for loop.
Put it in a for loop. I don't want to use a for loop. For loops are evil. I mean, there are certainly ways I could accomplish this with a loop, and I would like to avoid loop-based solutions for now, if you don't mind. Do you have an idea? Yeah.
Yeah, add a print 0 outside of the if-else statement.
Put it outside. Just put it out here, like there. Well, I think that, again, it's going to, I don't think that will work either, because this, again, will still produce 4 lines of output. And somehow, as that is in the middle of doing its work, I need to modify it so it will have zeros in front of those lines. And putting this here will still only do a single 0, right? You have an idea? Yeah?
So just like pass a prefix to it.
Pass a prefix. OK. That's a good idea. So do you remember we did this problem last week about crawling a directory? And we had to indent the different lines. And the way we accomplished that was we passed a string of indentation to insert at the front. And as we went further down the tree, we increased the indentation string with more spaces, right? So maybe what I really want is, you said pass a string of a prefix, like that. And so, OK. I like that idea. So here, you're saying instead of cout 0 and cout 1, you're saying print the digits minus 1 with like my prefix being 0 and my prefix being 1, like that? Is that kind of what you're thinking? OK. I think there's probably some other changes I need to make. This is close, but there's a few chunks that aren't glued together quite properly, right? If I'm passing prefixes, then somewhere I need to be printing prefixes, right? So, look, I'm really glad that we are where we are right now, because we're totally stuck, and this is totally fucked up. It doesn't work at all. And it feels like we're getting further away, and I love that. That's why I want us here. That's what I want. Not only because I enjoy your suffering, but that's part of it. I want you to see this is tricky. It's hard. It's a different kind of a recursion problem, and kind of unrolling this to actually do the right thing is complicated. It's kind of tricky. So let me jump back to my slides just for a second. So, OK. One thing I want to say first is we added a parameter to the function, a prefix parameter, right? And you don't always get to just change the heading of the function. Sometimes the instructor or the specification or whatever says it has to have this exact header. So if that's the case, you can either have 2 copies of the function, one that doesn't take the parameter and one that does, or you can have one of those optional parameter values. So like here, what I think I would do is I would say the prefix equals empty by default unless we pass a different value for it. So this way, the client on the outside doesn't have to pass a prefix just to get this thing started, right? OK. Well, OK, now let's think about this a little bit. If we make calls like print binary, 3 digits with no prefix, then we're assuming that that's going to lead to a call of printBinary of 2 digits with a prefix of 0, right? And printBinary of 2 digits with a prefix of 1. That seems like a good thing. OK. And printBinary of 2 digits with a prefix of 0. I mean, it's recursive. It's going to keep doing that same sort of thing, right? So that probably needs to lead to a printBinary of 1 digit with a 0, 0, and then 1 digit with a 0, 1, right? You understand the prefix gets bigger as you go down? And then that probably leads to printing 0 digits with a prefix of 0, 0, 0, and printing binary of 0 digits with a prefix of 0, 0, 1, and, or something. At some point, this stops, right? Like, so what I wanted to come back to was, I don't think we totally have the right cases here, and I don't think we're totally gluing them together. This prefix idea is a really important idea. And the way I think of this is, this parameter, this string that we're building, is remembering a set of choices we made before the current call. If the prefix has 2 or 3 characters in it, that means there were 2 or 3 calls before me, and those characters of that string represent the choices that were made by those calls. It's a time capsule from the calls before me, my ancestors, you know what I mean? And I'm going to use that plus myself to help contribute to the overall answer to the problem. And at some point, you get to the point where the prefix is the whole answer. The prefix is everything. The prefix is the entire binary number. The whole point was to print 3-digit binary numbers. And at some point, the prefix is a 3-digit binary number. That, I think, is the base case. So really, I think the base case is when we're printing 0-digit binary numbers. If you're printing a 0-digit binary number, I think in general that just means don't print anything. But we need to rethink what this digits parameter really means. You think of it as, oh, print the 3-digit binary numbers or print the 2-digit binary numbers. But I think of it differently now in light of this prefix parameter. I think of it as, that's how many digits that are left to be accounted for. We've already made a prefix of a couple of them, and I have to put the last one in. Or we've already made a prefix of one of them, I have to put the next 2 in. So if you get down to 0 here, it doesn't mean you're printing 0-digit binary numbers. It means the prefix contains all the necessary digits, and there are 0 of them left that need to be picked. So if I get here, what do you think I should do in the code? I should print the prefix. So this here, I totally get why we wrote this, and it's not useful code. It's wrong. The base case isn't 1 digit. It's no digits. And we don't print a 0 and print a 1. We print the prefix. Because now the prefix represents a full set of decisions that constitutes a 3-digit binary number. And that's the goal. So digits 1, no. Digits 0. See out 0 and 1? No. See out prefix. Only once. Why not twice? Well, I thought we needed twice to get the 0, 1 and to get the 1, 1. Where do the 2 come from? How do we replace 2 calls with 1? How do we get 2 outputs? Does that make sense what I'm asking? Like, it seems like if I just delete print statements, I'm not going to have the 2 anymore. Where does the 2 aspect come from? Do you know?
Well, in the recursive case, like when we do 0, maybe like when we do the prefix, we have to add a prefix to it so that then like you have 0 and 1.
The 2 aspect comes from the fact that we're making 2 recursive calls. The first one will print the 0 prefix value, and the other one will print the 1 prefix value. You made a good point about a bug here. It's not that we just put a 0 or just put a 1. It's like we have to think of it as this code has to work for all of the different calls, the first one and the 5th one and the 12th one and all of them. And so the prefix is all the things that came before me, and I want to retain that, plus I want to add a little bit to it. So you said exactly the right thing, which is the next call's prefix should be mine plus the little bit of contribution that I am making, which is the prefix from before plus a 0 appended on it. The prefix from before plus a 1 added onto it. This code, I think, is closer. In fact, it may even work. So the code morphed a little bit over time. I'm going to delete this or move this down underneath just so you can see the code kind of clean and all together like this. Now look at this. Usually when you got your recursive code right, it just looks real sexy like this. You know, it's just a couple of lines, and they're full of ninja magic, and it just works, and you don't really know why, and it just works. You know, have you heard You know, the two most common things people say about their recursive code, number one is, it doesn't work and I don't know why. And number two is, it works and I don't know why. This might be one of those number two case examples. But well, let me run it first. Don't take my word for it. Let's run it. Undefined reference to printBinary int. That's because up here it's looking for this, but I didn't in the prototype I didn't say string prefix equals empty string. One little detail: if you're doing prototypes for the functions at the top, you put your default value of the parameter here, and then when you go down to the actual place that you've written the function, you don't redeclare the default value. You just say prefix, and it'll use the default from up there. OK, let's try again. Hey, look. It's printing all of them properly. Now, again, this might be one of those ones where it's not really obvious at first that it would work, or how we got to here, and why does it work? Well, my most common suggestion for trying to understand recursive code better, I think you should do this a lot. Go download the examples that are weird from Lecture that are hard to understand and do this. Put a println at the start, print binary, and then put digits, comma, prefix, closing parenthesis, endl. Do that, because then when you run the program, it will dump a whole bunch of print statements of all the calls, and you can just read them. So let's read it. Print binary of 3, it produces, OK, so that print binary 3 with empty prefix, that calls print binary of 2 with a 0 prefix. Now, it would be easier to see if this were indented or something. So I'm going to pull this out and paste it into a text editor so I can indent it manually. So this 3 call leads to all of this. And this 2 call leads to all of this. And this 2 call leads to all of this. Do you see that? I mean, I'm indenting it to try to make it easier to see what's going on. So the 3 call leads to this 2 call with a 0. And this 2 call with a 1. You see those? Those are the 2 recursive calls made by that one. Then this 2 call makes this 1 call, and this 1 call makes these, and this 1 call makes these. So the 2 call makes this call and this call. And this is 0. Anyway, the ones that are zeros are the ones that actually end up printing output. These things right here are the lines of actual console output appearing here. So, I mean, you guys kind of see in the tabbing, I think, makes it actually readable to see what's going on here. Now, remember, the whole topic here is we're talking about exhaustive searching, walking through the space of all these binary numbers. Just the task of generating them was kind of hard, and we had to think about this in a different way. You probably were thinking for loops or something. Again, if you were thinking for loops, what I would say to you is you'd sort of want a loop for each digit or something. And if you don't know how many digits you have, you don't know how many loops you need. So recursion ends up being a really nice way to write this particular piece of code. Okay. Question on that so far? Does that sort of make sense, or what's fuzzy about it? Yeah.
Is it better to pass in a prefix? Because couldn't you use the same code, but the base case have digits equal 0, and then just cout endl, and then before each of the print binary, you have cout the 0 and then cout the 1. They would do kind of the same thing.
You got to have the prefix. If you do the couting, the problem is it won't put that in front of all of the thing. The thing that's really important to understand is each of these subcalls, line 45 and 46 here, each of them could lead to a whole bunch of lines of output being produced. And I need to make sure that a 0 and a 1 gets put in front of all of those lines. So any solution involving me printing cout one time will not accomplish that, because it will not inject that 0 or 1 in front of all of the many lines that may result from that subcall that I'm making. So it's really important to pass that along. Because if you really walk and follow through the tabs that I showed you, that 0 and that 1 become part of many later lines of output. That's the reason I need to pass them along. In the back, yeah?
Could we have done 0 plus prefix instead of
0
prefix?
plus prefix, put it at the front? Yes, I guess so, but it would reverse the digits, because the 5th call would put his digit as the first one in front of the other 4 calls that preceded him, And that's OK. Because in this case, I'm just generating all of the numbers, and so it would generate all of them still. I think it would just generate them in the opposite order. So that's not wrong. It would depend on the problem. Like if we needed to generate them in a certain order, then it might matter where we put our contribution compared to the ones from the prior calls. I put it at the end because I think of it as those prefix characters came before me, if there's 5 calls before me and I'm the 6th one, I sort of want to put my character as the 6th of the 6, because I'm the last person to pick so far, you know? Anyway, little different way of thinking. It's still recursive, and a lot of the stuff we learned last week still applies here, but I called it so far, like what I've picked so far in this version on the slides here. But okay, so one way some people think about it is like as a tree of calls. The initial call makes 2 subcalls, and each of those makes 2 subcalls, and each of those makes 2 subcalls, and at some point we get down to base case of 0 and we stop making subcalls anymore. And each of the ones that gets all the way down to 0, that becomes a base case and leads to a line of output getting printed out. And if you wanted to walk along this tree around it, just walk the perimeter of it, kind of once you hit the bottom, you would see the lines of output print out at that point or something like that. So we sometimes call it a decision tree because this piece of code conceptually is sort of deciding, what could I do next? I could do a 0 next, or I could do a 1 next. And so I guess the sort of general pattern here is think of printing a binary number as making a whole bunch of decisions. If it's a 7-digit binary number, you have 7 decisions to make. For each of those bits, do you decide that it's a 1 or decide that it's a 0? And each recursive call is going to handle making one of those decisions. I'll make one of those decisions. I'll handle one of those digits. And I will try making the first possible value for that decision, and I'll try making the second possible value for that decision, and then we'll see what could come after that. That's the pattern here. What if we were printing all the base 10 numbers with that many digits instead of base 2? The code is probably pretty similar, right? I'm not above copying and pasting from myself. So like if I came back here and I grabbed this, and I went down and I found printDecimal, print base 10, bless you, and let's do a string prefix again, and I paste this, I change binary to decimal, and decimal. What do I need to change so that it really will be decimal? Do you know? Yeah.
0 to 9, like.
Yeah, I need more of these lines. I need a 0, 1, 2, 3, 4. That feels redundant, right? So that seems like we would want a loop for that. Now, I think that would be fine to use a loop for that. I said on the previous problem, no loops, because I just didn't want us to get obsessed about looping, because the problem is recursive in nature. But we can have a loop mixed with recursion sometimes. We did that with the file crawling, because looping over the files in a given directory, that's an iterative sort of a process. But then walking down deeper levels of that is a recursive kind of a process. So I think you would say something like for int I equals 0, I less than or equal to 9, I plus plus. You want sort of prefix plus I, like that. And will that do the right thing? I think I need integer to string on I to convert the integer into a character. So let's try that. PrintDecimal. Let's jump up to the heading of PrintDecimal. I think I need to tell it that it has a prefix equals empty string. So let's compile and run. So here I'm doing PrintDecimal 2 digits. What does that do? Whoa. It starts 0, 0, and it goes up to 0, 9, and then it does 1, 0 up to 1, 9, and 2, 0 up to 2, 9. Goes all the way up to 99. And of course, what's really fun is typing in like 4 digits or something and running that. And we'll all just sit here and be mesmerized by the many, many, many lines of output that get produced. So anyway, we can generate all the numbers in a given range of binary or a given range of decimal. And I just wanted to point out that we used a for loop here, and we didn't use a for loop in the other one. We could have used a for loop, but it would have been a little silly because it would have been a for loop from 0 to 1. And that's not that useful of a for loop. But I just wanted you to see that it's OK to use a loop. You don't solve the whole problem using a loop. But remember what I said before. If there are many calls along the tree here, each of those calls is going to handle one of the decisions that needs to be made. And the job of that call is to try all the things they could do with that decision. So for my decision, I'll handle this digit of the answer. And that digit could have one of 2 values, 0 or 1. So I'll do something with 0 and I'll do something with 1. Or I'm going to handle this digit and there are 10 values it could have. So for each of those 10 values, I'll try making that value my choice, and we'll see what could come after. So that's why a loop is OK in this case. We're just using the loop to enumerate the 10 possibilities for the one decision being made by my call. OK. So let's go back here. This is another one of these rectangle thingies that doesn't show up properly, so forget it.